Z1 and Z2 are one of the roots, and it is given to me that the argument of Z1 is between half pi to pi. That means Z1 should be this, because the argument is between half pi to pi. So from here, I can identify Z1 to be 2e to the power of I, 7 over 10 pi. As for Z2, its argument is between minus pi and minus half pi, which means that Z2 must be this, because minus 9 over 10 pi is between minus pi and minus half pi. So from here, Z2 is 2e to the power of minus I, 9 over 10 pi. And I'm supposed to find the argument of Z1 minus Z2. Let me try to re-represent this on an Argand diagram. If I were to sketch out an Argand diagram, what we are going to have is something like this. This is the real axis. This is the imaginary axis. If it is this, that means it is going to be somewhere that is, let's say, here. The distance here is 2. The argument here is going to be 7 over 10 pi. I'm going to call this point here A, which is going to represent for me the complex number Z1. And as for Z2, its argument is going to be minus 9 over 10 pi, so it is going to be something like this, let's say. Okay, I'm going to call this point B, which represents for me the complex number Z2. And this argument here, this is going to be minus 9 over 10 pi. And if you were to want to find the argument of Z1 minus Z2, that means it is Z1 with reference to Z2. And if I were to draw a line here, the angle that I'm supposed to find is, if you were to be reference to the real axis, I'm supposed to find this angle. And this is going to be argument of Z1 minus Z2. And to find this angle, first let me find this angle here. This angle here is angle AO, if I were to call the origin as O, AOB. And angle AOB can be 2 pi, minus away this angle, 7 over 10 pi, minus away this angle, so 9 over 10 pi. That means this angle here is going to be equal to 2 over 5 pi. And finding this angle will actually allow me to find this angle here, and that is because I know this length here is 2 and this length here is 2. So if this is 2 and this is 2, what I have here is an isosceles triangle. So if I were to find the angle ABO, and this is just the base angle of an isosceles triangle, it is pi minus away this angle, 2 over 5 pi, and divide it by 2, since this angle and this angle are exactly the same. And this is equal to 3 over 10 pi. So I know now this angle here is 3 over 10 pi. And this little angle here is going to be 1 over 10 pi. How do we know that? Because here is 9 over 10 pi by interior angle, where the two parallel lines are here. That means this angle here is going to be pi minus 9 over 10 pi. So this little angle here is going to be 1 over 10 pi. So the angle that we are looking for, the argument, is going to be this angle, which is 3 over 10 pi, plus this angle, which is 1 over 10 pi. And this is equal to 2 over 5 pi. Next, we want to find modulus of Z1 minus Z2. And using my diagram, Z1 minus Z2, the modulus of it is actually this AB over here. And to find AB, what I'm going to make use of is, once again, this isosceles triangle. Because if I were to look at this isosceles triangle, if this is B, this is A, this is the origin, O. If I were to draw a line here such that it is perpendicular to AB, then this length here is 2, and this angle here is the same as this angle. And if this whole angle, we have already found it to be 2 over 5, that means this small little angle here is going to be 2 over 5 divided by 2. So this angle here is going to be 1 over 5 pi. That means we can find this length. To find this length, it is 2 sine 1 over 5 pi. By making use of the magic triangle that we have been talking about so much, in our topical outline. So AB is just going to be 2 times of this distance. So AB is going to be 2 times of this, which is 2 times sine of 1 over 5 pi. So this is equal to 4 sine of 1 over 5 pi, and this is what the question wants us to show.